Let's explore the stack data structure. In this video, we will be understanding stack operations and implementations. A stack is a fundamental concept in computer science that follows specific rules for how data is managed. So, what exactly is a stack? A stack is a linear data structure that follows the last in, first out principle, often abbreviated as LIFO. This means the last element added to the stack will be the first one removed. Think of it like a stack of plates or books. You add a plate to the top, and when you need a plate, you take it from the top. Elements are added and removed from the same end, which is known as the top of the stack. The bottom of the stack is the first element to be pushed in the stack. Let's discuss the basic operations performed on a stack. The first one is the push operation. The push operation adds an element to the top of the stack. The second operation is the pop operation. The pop operation removes the top element from the stack. Let's move on to the additional stack operations. We have the peek, also known as top operation. The peek operation returns the top element without removing it from the stack. The second operation is the IsEmpty operation. The IsEmpty operation checks if the stack is empty or not. It returns true if the stack is empty, otherwise it returns false. Now let's take a look at how we can implement a stack in Python using an array. Here we have a class called stack. Inside the stack class, we have a constructor denoted by _init_. This initializes an empty list called items. The push method adds an item to the end of the list, effectively placing it on the top of the stack. The pop method removes and returns the last item from the list, which is the top of the stack, but only if the stack is not empty. The peek method returns the last item in the list, which is the top of the stack, without removing it, again only if the stack is not empty. The IsEmpty method checks if the list is empty and returns true if it is, indicating an empty stack. Here we are using the Python's list as the underlying structure. Append is used for push operation. Pop function is used to remove and return the top element. Items open bracket -1 close bracket is used to peek at the top element. Now let's explore how to implement a stack using a linked list in Python. We start with the node class. The node class has a constructor that initializes the data and the next pointer to none. The linked list stack class has a constructor that initializes the top to none. The push method creates a new node with the given item. It then sets the next pointer of the new node to the current top of the stack, and finally, it updates the top of the stack to the new node. The pop method checks if the stack is empty. If it's not, it retrieves the data from the current top node, updates the top of the stack to the next node in the list, and returns the data. So, a new node is created and the new node is always added at the top. The top pointer will point to the latest element added in the stack. Now let's analyze the time complexity of stack operations. For both array-based and linked list-based stacks, the push, pop, peek, and IsEmpty operations all have a time complexity of order of 1, which is considered constant time. This means these operations take the same amount of time, regardless of the number of elements in the stack. The space complexity for both implementations is order of n, where n is the number of elements in the stack. This is because the space required grows linearly with the number of elements. Both implementations offer the same time complexity for all operations. However, array-based stacks might need resizing operations which can be amortized order of 1, while linked list-based stacks require extra memory for the node pointers. Let's explore some applications of the stack data structure. Stacks are used in expression evaluation, parsing and evaluating arithmetic expressions, and checking for balanced parentheses in code syntax. Stacks are used in function call management, managing function calls, local variables, and return addresses. Stacks are used in undo mechanism, enabling undo and redo functionality in text editors and design tools. Stacks are used in backtracking algorithms, solving problems like maze navigation, puzzle solving, and game state management in algorithms. Let's look at a practical example of using a stack, checking for balanced parentheses in an expression. We define a function as balance that takes an expression as input. We initialize an empty stack and a dictionary called brackets that maps closing brackets to their corresponding opening brackets. We iterate through each character in the expression. If the character is an opening bracket, we push it onto the stack. If the character is a closing bracket, we first check if the stack is empty. If it is, the expression is unbalanced and we return false. Otherwise, we pop an element from the stack and check if it matches the corresponding opening bracket for the current closing bracket. If they don't match, the expression is unbalanced and we return false. After processing all characters, if the stack is empty, it means all brackets were properly closed and balanced, so we return true. Otherwise, there are unmatched opening brackets and we return false. Here are the key takeaways from this video. Stacks operate on the LIFO last in first out principle. Elements are added and removed from one end only. It is a simple yet versatile data structure and is a fundamental building block in computer science. Stacks offer constant time, order of one operations, have simple implementations, are memory efficient, and are a natural fit for many algorithms and problems. Some limitations are: access is limited to top element only, no random access to elements, cannot efficiently search for elements, and fixed size in array implementation. Some real-world applications include browser history using the back button, text editor undo and redo functionality, function call management, expression evaluation in compilers, and depth-first search in graph algorithms. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.